Okay. Uh, when I started my career, I was working in robotics, man, and you had to be techno savvy to back to do robotics. And man, I was on it, man. Jeez, I don't know. I'm getting old, I guess. Okay, so anyway, recording now. You'll have the iPad. That will be there. You won't have intended something have any, and you won't. But anyway, so so I'll make it 100%. You'll see. Okay. Okay. Remember the equation? I do. Haven't written down here. So, what's the first thing you do taking an exam where you should quit because it says forget everything I've done, start fresh. You may have been doing something else, and all of a sudden it remembers the whole important thing. So do that. And then I'm going to type in the equations. I like type them all in. Equation equals y1 sine. Because I'm saying I'm going to call stuff, call it EQN. So whenever I say EQN, I'm going to, it's all of the stuff that I just typed. So it's one. Now it's a set of things. So I use the brace. I like to just follow the line. You don't have to, but I like to follow the line so it's cleaner. And I'm just going to type in the equation. And I can see them from the iPad. So trust y is equal y equals. It's an equation. One of the most common mistakes you'll make, especially under stress on exam, you'll forget two equals, and then it'll freak out. Okay, equals equals, and it's negative 0.04 times. I'll put in the star. You have to x squared. Is that good? Okay, comma. Second equation says x equals 10 times capital C because it's built in. It knows what cosine is, right? So COS bracket uh, 30 degrees, right? So I say 30 degrees. Okay, so it's all in radians. That's the pain in the neck. Okay, so let's see, times t. Notice I use star. You don't have to. You just have to put a space in it, right? Just put a space. Say, oh, give me one. Okay, the last one is y equals 10. Whoops. 10 cosine. Whoops. Sine. Sine of 30 degrees times t minus 1/2 times 3 out exactly 32.2 times t squared. And that's all. Yeah, you can't. It'll be, and I'm just trying to show off. That's all. And then I hit enter. And it comes back. This is what I think you said. And I look at it, and go, yeah, that's right. And if you notice, if I had used this point right here, 32.5 times 32.2, this would have been 5. That's only. Okay. It's do it this way, just like your math profs. They like to do everything with fractions, right? So anyway, so now what do you want to do? Solve. How do I solve? You say solve, right? With capital S. So you say, okay, solve. What do you want to solve? EQN. You could type it all in. Say equation. What do you want to solve? Y, X, T. You know, if it was so smart, it doesn't know that. I don't know. There you go. Why are there answers? It's quadratic. There should. Which one are you going to take? Second. Right. Take the second. How's that? Is that good? Oh, you know, the reason the number is 0.04. See that? I just noticed. How in the world did you notice that? Yeah. How's that? You want to see the? So if you plan to use mathematics, guys, so you must, right? Okay. I'm going to, here's how I do it. What I do is come in there and I say, all right, make up a problem. This is important. So I make up, then and I make up another one, whatever. Right? Then what I do is I wait a minute, come back. I've kind of forgotten about things, and then I stop watch and start timing, and I solve equations, boom, 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 all the way through, and I see how long it takes. Then I have a magic factor that I multiply my time by this factor. Say that's how long it takes to do it. Now I've been teaching for over 30 years. The factor works. Okay, I don't tell you what it is. It's a big number. You say, "Oh my goodness, I'm really dumb." If it's a small number, you say, "Oh my God, I'm going to panic." Do that, right? So, but it's a number and it works. So about 75% of you will be able to finish it. And you say, well, yeah, but you will feel like, yeah, okay, I could have done that, right? So that's what make up exams. Now, what I'm telling you is, if I make up a problem, I'm going to use mathematics on it. Okay? You don't have to, but I am. Okay? Okay? So I'm going to like carefully, slowly, boom, take my time, not rush through it. But that's what I'm going to do. So if you want to be able to solve the equations quick and you want to be good at mathematics, okay? If you don't, then it's on you, okay? Yeah, you have to show the yeah the answer. I don't have to zoom in. Hold more. So is this? Trying to show off and show that it would come out as symbols instead of numbers. But then I forgot I had 104, so let me do this. You know, just to show you what I was trying to. 4 divided by 100. So now it's do exact arithmetic like your math do. See, now everything's a fraction, no decimal, and then when you solve it, you'll do it that way as well. You see? And then, oh goodness, what? And so this number, yeah, I forgot. So you just divide capital N, and it'll give you. It wants to do that math problem, fraction. If you put anything, put the period, a dot, it'll do it all. Okay. Any any other questions? Yeah.
How would you put, say you didn't have degrees?
Uh-huh.
How would you put that on that?
Okay. Here's what I usually do. I say, okay, I always get angles, right? So I say angle equals 30. Okay, that's degrees. I need in radians. How many radians are in a degree? You know, version? There's pi radians and 180 degrees, right? So I'm going to multiply by pi over 180. Okay, there's your angle. Okay, and then here put angle, A-N-G. Does that make sense? Right? So degree is built in, so you don't have to figure out whether or not you have it. It's there. It knows what it is. Okay, so uh, will it find theta? Oh, you want a theta, simple theta. Okay. There's something up here in these pouches that, you know, if you like to click, drag, drop, and all that kind of stuff, if you pull up the pouch, it has some, I don't know, okay, but here's how I do it. I do escape, Q, escape, okay, but really, if you know, like me, I try to put these where students can read them and go, okay, got it. But if I were on an exam, I'd say theta equals, I'd say something, right? Theta. I'd write it out, rather than trying to remember it's escape, Q, escape. But it's under those palettes somewhere. I don't use those because I click drag on it. Okay. What do you think? Alpha. A, this A, escape. How about beta? B, escape. B, escape. What if you want to capital theta? Escape, shift, Q, escape. Okay, but you don't have fancy. It only really one. Say TH is theta. Okay, as long as you know it's theta, that's good. All right. Anything else? Okay, I'm going to go ahead and save it as is, and then I'll post it. But you read it. You know, all this is playing around. Okay, file, save, and oh yeah, I have to save. Okay. Okay, this is September 10th. All right, what you want to take this, right? Anything else? Because I'm going to go polar coordinates. No? Okay. If you do, send me an email, post it on Blackboard, do something. I'll be happy to try to do it and then post it. Okay. All right. All right. So let me cover the polar coordinates because you got to do that for sure. Okay. In order for you to finish your homework. So, what did I cover last time? Y'all remember? Tangent. Okay. So this is going to be similar. It's polar coordinates. What's going to happen is we're going to use polar coordinates for this. You don't necessarily have to know where the path is. You do have to something about how the thing's moving. So this would be the polar. I think your book calls them polar. That's what I call them, polar. Oh, of course I'm. Let's see. There we go. That's an O. Polar. Okay, so what happens is you got particles moving up here on some path, right? And there he is. There, that's the guy. That's the car, the truck, or whatever I have in. And what I'm going to do is to draw an origin down here. Okay, and I'm going to have a horizontal component, a vertical component. So that's my X and Y, and things like that for good at it, right? If you don't or if you use X, Y, what you do is you can establish a coordinate system. Polar is an angle. So what you do, very first thing you do is through the just like I did. That's the first step. Got it. Okay. Then what you do is you say, okay, that is the direction. That is the book uses U, R. It's the radial direction. So if I say on the exam, draw the radial direction, what are you going to do? You're going to draw a line from where to where. Origin straight to the particle points out. Always points out. Okay, from the origin. That's the positive direction. Then what's going to happen is you got the second direction. It's like there's X, Y. There's two directions here. The way you write it is the same way every single time. Okay, and rotate 90 degrees on the UI. 90 degrees. Which way? There you okay. I don't know where the angle is. It could be in the numbers. For example, it could be right here, right? And you could say that's angle theta. Maybe you know that. Maybe you want that, whatever it is. What you want to do is angle theta positive. Well, it looks to me like it's positive. It goes counterclockwise, right? Because it's being measured here up to here. Isn't that right? Okay, so that's a positive angle theta. It goes from X all the way around. counterclockwise is positive direction. You rotate 90 degrees, positive direction. You are. So in that case, I'm going to go 90 degrees from here. Boom. That's your theta. It's always that direction. Got it? U theta. I think the book calls it transverse. Okay, they gotta have a big name for everything, else they not feel important. Okay, but that's the transverse direction. Okay, let me give you the quiz. Here's the sky. There's that particle. Here's this one. Boom, boom. Okay, where's the radio? Okay, that's the easy one. Boom, there we go. I'm going to use this angle right here. I'm going to call it alpha. Where's the theta? Does it go?
Where's the U theta? Does it go this way? Right? Or does it go A or B? B. Here? It goes down, right? How do well, because which way is positive alpha? It's measured from where? From the Y over to this line. From here over to here. That's the positive direction, right? It's clockwise. See that? So I'm going to go 90 degrees clockwise from the UR. So now your positive direction is this way. That's the U theta direction. So the direction of theta depends on where you measure your angle. Is that clear? Okay. Now, I want a derivation. No? Good. Okay. These things can be tried. You just didn't want a derivation. If you do, it's in the. You do? Okay. Come by the office. Okay. If you write position, differentiate, you will get the velocity. Derivative of position equals velocity. It's a little bit complicated. Your book talks about it. If you really do want to see it, come by. I can do it. It's not like I can't, but I know that most of you could care less, and it doesn't help you solve problems. So here's the answer that I'm going to get. I'm going to find out that the velocity of this guy is equal to r dot. What is that? Time rate of change of the r, which is the distance. I should find that, right? That's the distance from the origin to the particle. That's r. Okay, r dot in the r direction, just like there's the x and y and I and the j. It's got that much plus r theta dot in the u theta. Now, if you're calling your angle alpha, then it would be alpha. Whatever is your angle, it's the derivative of the angle. Everybody got it? Okay. The acceleration, you don't need derivation for that either, right? But the acceleration, the result of the acceleration looks like this. Acceleration equals, let's see, I'm working off of memory. This is r double dot. Whoops. Double dot. Come on. Minus r theta dot. Come on. Square. In the plus 2 r dot theta plus r theta dot dot. Okay, that's a complicated one. I can write that down. Okay, those are five. One of the things that you can do that helps when you have equations like this, you're not sure if you've done it right, is count the number of dots. Velocity terms, all velocity terms should have one and only dot. Okay, so look at the velocity. You see the dots? This guy right there. There's a term. How many dots? One. How about this guy? How many dots? One. Okay.
It's not conclusive, but you could have mistake put a negative there, right? So it doesn't say, oh, sure, right. But sometimes you'll be in the middle of college and say, well, it's not an dot, and then you did something wrong. Now, typically in this class, the problem's going to be simple enough you don't need to worry about it. When you get out of practice and you do something like this, they're never going to give you an easy problem. And there's never going to be somebody who says, oh, no, you just made a mistake here. No, if you make a mistake, it's going to cost somebody money or maybe life, right? And you do enough of those and you will lose your job, right? So what you want to do is you want to have every trick you can to say, this can't be right. I'm not going to turn this in until I find my mistake, okay? How many dots here on the screen? How many here? How many? It's a square term. So theta dot, right? So there's two. How about here? In the term, two. How about here? Two. Right? So at least the path is that. Okay? That's something that maybe. How about we do? Okay. Let's see. Okay. I actually pulled it up. There we go. How about 167? The car travels along the circular curve. Car travels on a circular curve having a radius 400. At the instant shown, angular rate of rotation is theta dot equals, which is decreasing at the rate of theta double dot. Determine the radial and transverse components of the car's velocity and acceleration and sketch the components. Okay. Now, I'm going to give you an exam. The exam may use X and Y. It may use normal. It may use R theta, right? Here, the thing in this section is going to be R theta. On my exam, you're not going to know. So you have the first thing you're going to have to do is figure out should I use XY, tangent normal, or R theta. Now, what I would do is rule them out. Okay. Sometimes, okay, and if it's obvious, you say, look, I don't know why you spend time on that, but oftentimes it may not be obvious. I'm going to tell you how I choose which one I'm going to try first. Right? Okay. First thing I look for is maybe it's tangent normal. Okay. Those are the most rare I have found in the real world. Right? What do you know in order to use tangent normal? Remember what it was in the lecture last time? You got it. Got it. Step one. Oh, okay. Do I know the path? Circle. Radius 400. Yes, you do. So circle radius 400. I know the path. Okay. Let's think about the equations for tangent normal. What kinds of things into those equations? You're going to write them down. So eventually, what kinds of things go into those equations? Yeah, speed. You're going to write them down, right? So eventually, you'll be able to look on your notes and say, yeah, it's radius. Right? Do you know that? Speed. I do. Do you know the speed? Radius. You do? What's the speed? Yes, I do. Do you know the speed? What's the speed? I know theta dot. I know the speed. That's not speed. What's the speed? Right? That's theta dot. That's how much. I don't know the speed. Yeah, sure. It's not speed. Speed. Right? That's how much the angles change. I would say, well, rule it out. Yeah, sure. You could figure out the speed, right? But it's not given. Rule out. I don't know speed. I would say. Does it want to know speed dot? No. I'd rule it out. Don't use it. Okay. Second thing, first, RA. Okay. What do you need to know? Second thing, you right up there. R theta. Okay. What do you need to know in order to do R? You need R. They're right up there on the iPad. What else? R dot. You need theta. R double dot. You need R. theta, theta double dot. Do you have those? Hot dogs, do it. Right? It's pretty obvious, right? I mean, all of things given to you, you say, man, that's obvious. But I don't know why he's beating a dead horse, okay? Because I won't know, right? And that's the process I use when I decide what coordinates is somebody. Okay, let's do it. Okay, I'm going to skip to a new page. You might want to find these equations in your book, or trust me, I'm going to get them right. Okay, here we go. Page. Okay, we're doing problem 167. All right. It says determine the rate of transverse of the car's velocity. Okay, here we go. I've decided it's all theta. So I'm going to write down the equation. V equals R dot UR plus R theta dot U theta. Okay? All right. V equals, what's R dot? Why is it? Why is R dot? It's a circle. The radius doesn't change in a circle. What's the change in? No change. R dot. Got it? U plus, what's the R? 400 feet. What's theta? 0.025. And that'll be in the U theta. Okay, can you solve that? Would you? Yeah, 400, right? Math is a tool. It shouldn't be torture. Okay. So whatever tool you need, not gonna, you can probably in your head, right? Isn't it? Let's see, 4 times 2,500, 30.1, right? Whatever you need. Okay. Then it says, okay, so I need to sketch. Okay, so here we go. Here's the circular path. Here's the origin where everything's being measured. Where's the car? Straight up here. Okay, need to find the theta. How do I find the theta? What do you do first? Draw the arc. First thing you do is the arc. And when you get some here, just I know what it is. Get away. Just get away. But until you get good at it, step one, all the arc. Zoom. There's the R. That's UR. Now rotate 90 degrees. In which direction? Well, you tell which is positive. See that? You're trying to tell me counterclockwise. That's the way they're measuring their angle. See that? Okay. Which way is positive? Counterclockwise. Where does U theta go? Right or left? Goes left. Right? Take 90 degrees counterclockwise. Right there. There's the U theta. Okay, so where is velocity? Velocity is right here. There's the car, and he's equal to 0.1, and he's going in U theta direction. So he's like that. 0.1. So I now, is that tangent to the path? How do you find the tangent? Here's the path, right? This guy right here. Isn't that the path? Yeah, that's the path. Circle path. Doesn't look like a circle. Okay, and it's right there. Ah, what's the tangent there? Horizontal. Is the velocity tangent to the path? Yes. Velocity always tangent. It might be along the path, he's going, or he could be in reverse, going backwards, right? But it'll always be tangent. Always, 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 always. You don't know what path he's going. Find out what direction he's going. That's the tangent. Wait a couple seconds, find out which direction he's going. Plot that. That's the tangent. You can probably connect the dots and find out what path he was on. Make sense? Always tangent to the path. Okay. What is v? The speed. That's the magnitude of his velocity. What's the speed? It's on the iPad. 0.1. Speed is 0.1. It's tangent to the path. So now it almost looks like I could use tangent normal, right? Because now I know the speed. Ha! So I could change. Let's, right? But you could, right? Now you know the speed. Don't know the speed out yet, but you do know the speed, right? Any questions? Okay. How about we accelerate? Yes. He multiplied in my head, and I did it wrong. I multiplied 400 times 0.025. Did I get it right? Did I get it right? Oh, well, answers. I go trying to be smart ass, right? Okay, so what is the answer? 410? Okay. I knew. I was just waiting for you all to. So this is speed is 10. How's that? Why do you let me get away with it? Now it's recorded forever. Yeah, you see, Everett's video. Look, whatever. Okay, let's get acceleration is. I'm going to write it down first. It's r double dot minus r theta dot. You are. Ah, how do you know it's a square? Because you got to memorize. Because it's got to be 2 dots. So you know I've made a mistake, right? So it's r theta dot squared plus let's see, 2 r dot theta dot. Write this one down on the sheet plus r theta double dot. I think the hardest thing in these is just writing the equation. U theta. Okay. What are we going to? I'm going to see if we plug into. Okay, acceleration equals. What's our double? I'm going to see if I can plug into this. Okay, acceleration equals 0, right? R is constant. R dot is the derivative of a constant. 0, 0, 0, 0, 0 forever. What's the change in 0? Nothing. R double dot is 0. Minus what's R? No, R is not 0. 400 feet. 400. What's theta dot? No, R is not 0. 0.025. 0.025 squared UR plus 2 R dot 0 times theta dot 0.025 plus R is 400. What's theta double dot? Yeah, negative. Oh, okay, negative 0.008. That's not 400 minus that. That's 400 times that. Negative. Oh, okay. And negative 0.008. That's not 400 minus that. 400 times that. Okay. So let's see. 400 times 0.025 squared. I'm not even gonna try that. It's 10 times 0.025. So 0.25. Did I get that right? 0.25 squared. I'm not even gonna try that one. You're not gonna tell me. Times 0.025. 0.25. That'll be the UR. You're not gonna. It's a theta dot right here. It was. It says theta double dot. Let's see. Plus, excuse me, minus 408 times 4 is 32. So that'd be boom. 3.2. Get that one wrong. 408 times 4 is 32. Yes, it is. Thank you very much. And minus 0.2.
Yes, it is. Thank you very much.
Now they want
Minus
to sketch,
3.2.
right? So what I'm going to do is I'm going to say, okay, I've got the diagram right there,
Now they want me to sketch.
right? So don't redraw it. So where's the
What
U
I'm going to do is I'm going to say, okay,
points up?
I've got the diagram right there.
But this is negative,
Right.
so it's going to go down,
Redraw it.
right? So this guy is to be
Points up.
the 0.25 down this
This is
way
a negative.
at
So it's going to come down.
0.25.
Right. So this guy is
The U thing, that is left,
0.25. He's going to
but he's negative,
at point.
right? Negative. Which way does it go? To the right.
The U thing, that is left.
Through
Negative.
3.2. Okay.
To the right.
Yes. What is the tangent acceleration?
3.2. Okay. Now let me ask you.
3.2. That's the tangent direction.
What is the
right?
tangent?
3.2 is speeding up, slowing down. Slowing down because he was going 10 to the left.
Right.
He's accelerating 3.2 to the right, slowing down, right? If you wanted to be precise, you'd say he's decelerating. Decelerate simply means you're slowing down. Accelerate just means that you're changing your velocity. That's all it means, right? So like everybody in this room is a human.
Accelerate.
You are, right? Okay. Everybody in this room is a human. Some of you are male, right? So that's like, this is an acceleration. It happens to also be a deceleration. Got it? Okay, so deceleration simply means, hey, I'm going, that's it. Okay? Acceleration could mean going faster, slowing down, which means you're changing. Acceleration, yes. Okay, what is the 2.25? What's the normal component of acceleration? Where's the tangent? You know where the tangent is, right? There's the tangent.
What's the
Where's
normal
how do you find the
component
normal?
of acceleration?
You go 90 degrees
Where's the
tangent
tangent? You know where the tangent is, right?
inward,
Where's the
right?
normal?
Always
How
inward.
do you find the
So
normal?
where's the tangent pointing out? Is this
You
the
go 90
tangent?
degrees off the tangent.
Oh, excuse me. This is the tangent.
Inward,
Sorry,
right?
that's the tangent.
Always inward.
He's going that way, it's like the left.
Pointing out, is this the tangent?
If he was traveling to the right, tangent go to the right. The tangent always goes in the direction
Because he's going that
you
way,
are.
that's why it goes left.
Okay, then you take 90 degrees off
Tangent would go to the
tangent.
right.
90 degrees off.
Tangent always goes in
Yeah.
the direction
Inward.
you are moving.
Which way is that?
Okay. Then you rotate
Down.
90 degrees off.
So is this guy normal
This guy. Inward.
or is he
Which way is
negative
that?
normal? He's the negative of normal.
Down.
Okay, so what is the normal acceleration?
Or is he negative?
Is it negative?
Of the normal.
It's
Okay.
0.258. The
Acceleration.
normal acceleration is 0.25. Got it?
Negative.
What's the radial
It's 0.25
acceleration?
inward.
Radial acceleration
The normal acceleration
minus 0.25.
Got it?
What's the
radial
normal
acceleration?
acceleration?
Radial
Positive
acceleration
0.25.
minus 0.25.
Right? Positive 0.25.
What's the normal
Is the
acceleration?
normal acceleration
Positive
ever
0.25.
negative? Think about
Right?
the formula. Normal
Positive
acceleration. Normal.
Is
The formula
acceleration
speed
ever negative?
squared divided
Think
by
about
radius.
the formula. Normal
Is the
acceleration.
speed
Acceleration normal.
positive? Be negative.
Was speed
Square it.
squared
Positive. Always.
divided by radius.
What about the radius?
Is the
Had a
speed
negative.
positive?
Nope. Always positive.
Negative.
Positive radius.
Square
The
it.
normal
Positive.
acceleration
Always positive.
never.
What about the
No.
radius? You've ever had a negative radius?
Is the
Nope.
radius
Always positive radius.
acceleration
Is the
ever
normal
negative?
acceleration ever negative?
Oh, come on.
No.
Is the radial
Is
acceleration
the radial?
I don't understand. So the radius can be negative, but the normal is never. See if this. Okay, let's say you're driving your, right? This is getting into this chapter, but I think you can do this. Y'all equals A. Force equals mass times acceleration. Okay. So you drive your car. Okay, it looks like my piece. Okay, you're driving. I'm doing 9 miles and I turn right, left, on a like this. Which way? It's inward, ways in, turning left. Okay, so there's my. Okay, where's the force? Why is this? Right? But Newton said F equals ma, the A. How come F is? It is. It is. Imagine you're okay, and I final flat, you know, some silk pants, whatever. Oh, you got no. You got no. I got no. I have a door. Okay, door's closed. I hang a left. What happens to you? Don't you go like to smash up the window? Okay. Okay. So where's the right here? The window is touching and pushing you away. That way, right? Force is that way in the direction of acceleration. What do you feel? You feel like you're. What your body's telling you is you always feel the opposite of what's happening in your acceleration, and that's going to confuse you class because you're going to say, "Oh, it can't be that way." Because, you know, I've been done it, and I feel it doesn't matter what you feel because your body always feels the opposite of what's really happening to you. You're in a jet. It's not okay. You're in a jet into the runway. Okay, it doesn't to the metal. Your weight isn't like you're thrown backward. Is that what's happening? No. The seat is smashing on your back and saying, "Come on, stay with the airplane." So your force is that way. Your acceleration is that way. See that? So what you feel is the opposite of what's really happening to you. Okay? So in this particular case, you're hanging a left, your acceleration is down. There will be a force pulling you downward. If you don't have enough tire force on your tires, right? If you don't have enough friction on your tires, which way is the car going to go? He's going to go straight off that way. If you ever go inward, right? So you're going to go off the road that way. Why? Because you don't have enough force to keep you on this circle. You hit ice, no friction. And he said, "Well, I don't have a force. I'm not going to accelerate." And off the track. Got it? Okay. Lecture. Let's see if I got my iPad back or not. Nope. I don't know what this thing works everywhere. Here, huh? Okay. I still have some time. I want to do another problem. I'll do it on the board. Okay. I'm going to stop the recording because what's the point? Pause